recorder is on. And I'm going to start by sharing my browser with you just to show you where we are in the course. Okay, so here we are in our course, and we are currently in week 3. You could see these assignments are due by September 12th on Sunday. We have 2 sets of homework, one on inverses and this one on determinant and Cramer's rule. I am going to be using this determinants and Cramer's rule notes right here. Okay, so this is what I'm going to be working off of. Just to let you know in advance, like I said, there's not a whole lot of new material here. It's yet another method of solving systems of equations. And the idea was back in the day, before there were calculators, you would have your pick of methods and you'd pick the easiest method. Like I said, Cramer's rule in particular is useful if you just need the value of one of the variables in a system as opposed to all of them. Okay, I also want to call your attention to this grade check assignment down here. Don't forget about it. There are 4 of these in the course, and they're an opportunity for us to have a conversation about how you're doing, how you think you're doing, whether you need any assistance, and what I can do to help you out. Okay, so please, again, this is a really quick assignment. And I do look at those and I do comment. I will respond to your comments in there. Okay, so I'm going to begin by sharing the determinants and Cramer's rule notes. I'm going to leave out, open the chat in case you have comments, but please feel free to unmute yourself and just ask if you have questions. Okay. All right, and let me share this with you. Sorry, this is going to take me a minute to get the sharing going. All righty, and now we should see more on matrices, the determinant, and Cramer's rule. Okay, can everybody just give me a shout out? Everybody's seeing that.
Yes.
Okay, good. All right, so this concept of a determinant it's a number that's going to tell you something about the overall structure of your matrix, which again is a topic for a linear algebra class. We're not going to go into those details here, but we'll show you how to find the determinant, and I'll show you how to do it manually. But when you actually need to do it, you're going to use the determinant function in Symbolab. Okay, there's also, again, nobody in the class is using a TI-84, but there's one built into the matrix math menu there as well. Okay, so a determinant, first of all, it's going to be of a square matrix, okay, an n by n matrix. It's denoted in one of 2 ways. That means you write it in one of 2 ways. You either write the word DET with the name of the matrix in parentheses, or you can put vertical bars around the name of the matrix. Now, this can be somewhat confusing because we've seen these vertical bars before in math. Okay, anybody remember what vertical bars mean so far in math? Anybody remember? Okay, they can represent an absolute value, but that's usually when you've got a number in the vertical bars. This is another one of those examples where context kind of tells you what you're talking about. Okay, so this looks like absolute value, but it's not. It's another one of those examples where we're going to use the same notation to mean something different. Okay, this happens a lot in math. That's part of what makes math difficult when you first, get involved with higher math, is because you have to constantly be looking at the context. Okay, if we're talking about matrices and we have a matrix inside the vertical bars mean determinant. They don't mean absolute value. Okay, now it's a scalar value. Scalar, remember we talked about last time, it's just a number, not a matrix. Okay, so we're going to calculate this determinant, and it's calculated using the diagonals of the matrix. Okay, so again, I'll show you how it's done by hand. Okay, and again, like everything else, it gets more complicated the larger the matrix. It's pretty easy for a 2 by 2 matrix like the one I'm showing you here. Okay, so matrix A has entries A, B, C, and D. And again, I'm just using those rather than numbers to show you the pattern of finding a determinant of a 2 by 2. Okay, you multiply diagonally down from the top left to the bottom right. So you get AD, and then you subtract the product in the other direction, BC. Okay, so that's essentially how you find the determinant. That's going to give you a number. Okay, so here's an example with actual numbers in. Okay, so here you would have your determinant of A would be 1 times 4 minus 2 times 3. Okay, so that would be 4 minus 6. Your determinant is -2. Okay, now again, it might seem kind of pointless to do this. If you remember when we briefly showed you the manual process for doing inverse matrices, there was one method that said, well, you could use a determinant to figure out an inverse without going through the Gauss-Jordan elimination. Okay, so determinants are used to find matrix inverses. Okay, and they're also used in finding the solutions to a system using this Cramer's rule that we're going to talk about. Just again, be aware that they have uses beyond that, and they reflect the structure of your matrix to some degree. Okay, so again, if you wanted to do it, you just multiply left to right diagonal, right to left diagonal. Okay, and again, Symbolab has this built in. Let me just briefly show you that in Symbolab. Okay, we got -2 doing it by hand. Here's my matrix calculator in Symbolab. Okay, and again, I would just write the word DET for determinant. And then I have a 2 by 2 matrix, and I put my values in like that, and then just say go. Okay, and you can see here's the determinant value right here. Okay, so in Symbolab, super easy. Just write DET in front of the matrix that you want the determinant of. Remember, it's got to be square. Okay, so 2 by 2, 3 by 3, and so on. Okay. Again, let me just show you how it's done for a 3 by 3 matrix. Okay, so again, I'm just showing you the pattern that's involved in finding a determinant. Okay, there's a little strategy that kind of makes this a little easier. You can see I have my 3 by 3 matrix here, A, B, C, D, E, F, G, H, I. What I'm going to do is I'm going to rewrite the elements in the matrix, and then I'm going to copy the first 2 columns. So here was my original matrix. Okay, and then they say, copy the first 2 columns to the right of that. Okay, so I'm going to copy A, D, G. That's the first column. And again, I'm not quite sure why it's taking so long for this to render. I'm seeing it on my tablet, but it's not showing up on the screen right away. So again, let's just be patient. Then B, E, H. Okay, so I took this column and copied it to the right, took the second column, copied it to the right of that. Okay. And then they basically, what we're going to do is we're going to form left to right diagonals. So here's that one. Okay, the second one is this one. Okay, and the third one, again, I'm going to have to get my C out of there. Here's my third left to right diagonal. Okay, so those are my left to right diagonals. Okay, and I'm going to copy those here. AEI plus BFG plus CDH. Those are my left to right diagonals. Okay, diagonals down. Okay, and again, here it says northwest to southeast. Okay, and then what I would do is I would form the diagonals going up. Okay, or as they say, from southwest to northeast. Okay, and they are basically GEC, HFA, and IDB. Okay, so you first form your downward diagonals going from left down to the lower right. Okay, by multiplying the numbers that are on, in those diagonals. And then you're going to subtract the products from the diagonals going up. Okay, so that's the overall structure of it. Okay. Anybody got questions on how we did it? We kind of used a bit of a hack to do it, but that's fine. Hacks work. Okay, so if I was ever stuck and I needed a determinant and I didn't have access to the internet or a TI, I could still do it. Okay. All right, so here's one that actually has numbers in it. So I'm going to use my strategy to find the determinant of this matrix. So I'm going to copy over the numbers. And then I'm going to recopy the first two columns to the right. Okay, and then I'm going to form first the downward diagonals. And you'll notice if you look at the diagonals, you can't make a diagonal here. It's too short. The first diagonal you can actually make is the 219 because they have to have 3 entries on them. Okay. And then the second diagonal is 435. Again, it's for some reason, it's not writing on the screen. Not sure why that is. Okay, there we go. And then 687 is my third diagonal. Okay, so I'm going to write those numbers here. 2 times 1 times 9 plus 4 times 3 times 5 plus 6 times 8 times 7. Okay, so those are my downward diagonals. Okay, again, I can just calculate these with a calculator. Okay, if I bring up my TI-84, okay, let me share that with you. Okay, you move it over so it's not in the way. All right, so I'm going to clear that. And I have 2 times 1 times 9 plus 4 times 3 times 5 plus 6 times 8 times 7 is 414. Okay, so again, I'm just showing you the manual process. Totally get that we're not going to need to do this. Okay, So then what I need to do is I need to figure out what my upward diagonals are. Okay, so those are going to be 516, 732, 984. Okay, so 516 plus 732 plus 984. And again, those are multiplied and then the products are added. Okay, so I can pop up the TI again and do those. Okay, and I get 360 for that product. Okay, and again, if I want the determinant of A, that's going to be the downward diagonals minus the upward diagonals. Okay, so I can do that here. And I get a determinant of 54. Okay, you'll notice it, again, depending on the numbers in here, these numbers are all positive. They're a bit large, so your determinant is going to be a bit large. Okay. Now, again, we can check by putting this determinant in Symbolab and see that we get 54 out of it. So let me just do that really quick, just to show you an alternative way. I'm going to leave the word determinant in there. And then I'm going to put my 3 by 3 matrix, which was 2, 4, 6, 8, 1, 3, 5, 7, 9, and hit go. And here's the 54. Okay, so again, part of the reason for showing you the manual process is historical. Okay, up until maybe 10 or 15 years ago, we didn't have software that could calculate it, so you had to do it by hand. But the more important reason is because it has applications in linear algebra beyond what we're just using. And like I said, it has implications for the structure of the matrix, which again are beyond this course, but are going to be useful if you ever wind up doing anything with linear algebra later, particularly if you get more involved with statistics in your career. Okay, so let me stop at this point and ask, do we have questions? Questions on finding the determinant of a matrix? Questions? Okay, so again, Symbolab is the way to go. All right, if that's what you have available to you. Again, if you're stuck doing it without an internet connection or without your TI, by all means, you can do it by hand. But again, remember, Symbolab's an app. Download it for your phone. Okay, so you have it with you wherever you've got your phone and a cell connection. Okay, so we've got this determinant. Like I said, it can be used as a shortcut for finding matrix inverses. But what we're going to use it for, okay, is we're going to use it in Cramer's rule. Okay, so here is a kind of a reminder. If you have a matrix A, a 2 by 2, A inverse is this thing, which we know now is the determinant of A, 1 over the determinant of A. Let me write it correctly. Okay, so this fraction out in front is 1 over the determinant of A, and then they just switch A and D, and then they negate B and C. Okay, again, it has to do with the structure of a matrix. Realize when you do Gauss-Jordan operations or when Symbolab's doing them, okay, what comes out is related to the internal structure that went in. Okay, so that's kind of why there's a quick formula for a 2x2 inverse. Okay, so let's talk about Cramer's rule. And again, this was originally designed for you to do some research, but I'll walk you through it. Okay, so ideally, we would research Cramer's rule using Google, right? And we can look up keywords like Cramer's rule matrix, and then describe it. Now, why would I put an assignment like this in here? Well, when we do this in class, the idea is to give you an opportunity for looking up useful information on the internet. Another thing that you probably are going to wind up doing in your careers is finding out things that you don't know the answer to. Okay, remember we talked about that a little. How do you know your answer's right if there's no answer key? Well, one way is you collaborate and you try to convince each other of your reasoning. And the other way is you research things, you try to get more information. Well, we've only got 5 people in our group here, and, maybe we should leverage the power of the billions of people on the internet and see what they think. Okay, so that's kind of research. And I'm sure you all realize there's better sites to look things up on than other sites. Okay, so you kind of probably don't want to use Reddit for math questions, okay, but you want to use more math-oriented sites like maybe Stack Overflow or some of the others. As you do research, you get more familiar with what sites have better quality answers. That's another thing that you develop when you do research on the internet, is you develop that sense of judgment of, the answers I've gotten off of this site are a little flaky. Maybe I should try a more math-oriented site. Okay, so here's what I found out about Cramer's rule. Okay, it uses determinants. Right, to solve a system of equations. Okay, and basically, or like I said, useful for solving for one variable. Right? So for example, let's say you had a system of equations that represented something in the real world, say a physics problem. You wanted to tweak the equations, but you were only interested in one output variable. You don't want to solve for everything again. Okay. Cramer's rule would be the way to go. Okay. Because you don't have to solve for the whole thing. Now, nowadays, since we have things like Symbolab that make it very easy to solve a system for everything. Okay, the distinction has gotten blurred, has gotten less important. Okay, but like I said, it's always good to have a bunch of different ways to approach a problem because they give you more insight into the structure of your problem. Okay, and they have uses beyond what you're actually doing. So here is the way you do Cramer's rule. Okay, find D, the determinant of your coefficient matrix. Okay, and again, I will write this out a lot nicer when I upload my notes. So find D, the determinant of the coefficient matrix. Then you're going to find a bunch of other matrices. Build the, let's say we have a system of 3 equations and 3 unknowns, X, Y, and Z matrices. By replacing the appropriate column in the coefficient matrix with the right-hand side values. Okay, so basically we're going to take the same coefficient matrix, and if we're interested in the X matrix, we're going to replace the first column, which represents the variable X, with the right-hand side values. When we build the Y matrix, we're going to start with the coefficient matrix and replace the second column, which represents the variable Y, with the right-hand side constants. And lastly, when we build the Z matrix, we're going to start with the coefficient matrix and replace the third column with the right-hand side constants. Okay, so that's how we're going to get these X, Y, and Z matrices. Find the determinants of each of these matrices. Okay, and we're going to call them D sub X, D sub Y, D sub Z. Okay, and they are going to be the determinants of again, having some issues with there we go. Okay, of the X, Y, and Z matrices that we built in step 2. All right, last step, to find X. Okay, you're going to take the determinant of your X matrix and divide it by the determinant of the coefficient matrix. Y is going to be the determinant of the Y matrix divided by the determinant of the coefficient matrix. And Z is going to be the determinant of the Z matrix divided by the coefficient of the determinant of the coefficient matrix. There we go. Okay. So that's it as a recipe, which isn't very satisfying, okay? Because again, you kind of want to see how it works. And what we're going to do is we're going to leverage building the determinants onto Symbolab. Okay, so here is a system of 3 equations and 3 unknowns. Okay, so the first thing to notice when you look at systems of equations or inequalities is you want them in standard form. What do I mean by standard form? Is you want all the variable terms on one side and you want all of the constant terms on the other. Okay, if you get equations that aren't in standard form, like the variables are on both sides, you need to put them in standard form before you build a matrix. Okay. Also, we saw last time, if any of the variables are missing, like say I didn't have an X here, I'd have to use 0 as a placeholder in the matrix. Okay, so I'm going to build my coefficient matrix A. Okay, I'm not going to, I'll call it A. Okay, and then I have a 2, a 1, a 1, a 1, a negative 1, and a negative 1, and a 1, a 2, and a 1. Okay, so remember, just the coefficients. Okay, not the right-hand sides. Okay, that's how you're going to get a square matrix out of it. Okay, anybody questions about building the coefficient matrix? Okay, then what I'm going to do is I'm going to find the determinant of A, which I'm going to call D. Okay, and I'm going to do that by going over to Symbolab. I'm going to take this matrix, okay, and hopefully you're following along on your notes or something. Okay, so you have the matrix written down. So let's go over to Symbolab. And I'm going to put another 3 by 3 in here, only I'm going to put these coefficients in. So I have 2, 1, 1, 1, negative 1, negative 1, 1, 2, 1. Okay, so that's the coefficient matrix. I have DET out in front. So you can see I got a determinant of 3. Okay, so I'm just going to make a note of that determinant value in my notes. Okay, and kind of keep that off to the side. Okay, then I'm going to build my X matrix. Okay, so here's my X matrix. I'm going to build a Y matrix and a Z matrix. Okay, and basically what I'm going to do is I'm going to start with the coefficient matrix, and I'm going to replace the relevant column in there. Okay, so now normally my first column is X, my middle column is Y, my last column is Z. Okay, so what I'm going to wind up doing is I'm going to wind up replacing those columns in these matrices with the right-hand sides. Okay, so I'll just copy over the coefficient matrix in all of these, and then we'll go back and we'll erase the column that is going to be replaced. Okay, so again, sorry, let's pop back here. Mirroring stopped. So let me see if I can share that again. Did I pop off this? Oh, I'm still sharing that. Okay. Not really sure what's happening, folks. Give me a minute. All right. Let me stop sharing. Let me disconnect my tablet and try again. There we go. Sorry, every now and then I get glitches. Okay, so here are my 3 matrices. This one's going to be the X matrix, the Y matrix, the Z matrix, and you can see I've started with my coefficient matrix. Okay, so for the X matrix, I'm going to erase the X column, and I'm going to put in the right-hand side of my system, which is 3, 0, 0. Okay. For the Y matrix, I'm going to erase the middle column and put in 3, 0, 0. Okay, everybody see where I'm getting the 3, 0, 0 from? And in the Z one, I erase the last column and put in 3, 0, 0. Okay, that's how you get the X, Y, and Z matrix. You replace the relevant column. And what do I mean by that? The one that corresponds to the variable you're interested in, right? This is X, this is Y, this is Z. Okay, and then I'm just going to find the determinant of each of these. This is going to be dx, dy, dz. Okay. So that means I need to go back and I need to, in Symbolab, replace in the coefficient matrix the relevant columns with 3, 0, 0 and run determinant 3 times. Okay. Everybody understand the strategy? Everybody good with the strategy? Okay. So I'm starting out with my coefficient matrix and I'm just going to replace the columns one by one. All right, so here I am back here. Right, and I have my 3 by 3. First one is going to be 3, 1, 1, 0, -1, -1, and 0, 2, 1. Okay, that's my X matrix. Okay, with the first column replaced by the right-hand side values. All right, I'm going to hit go to get its determinant. And you can see that determinant is 3. And I'm just writing it in my notes. Okay, the second matrix, I have to put the coefficient back in. Okay, so here's my coefficient matrix the way it came. Okay, and I have to now replace this second column with 3, 3, 0, 0. Okay, and then find that determinant. That's for the Y matrix. That gave me -6. Okay, I'm going to put the original coefficient matrix values back in here. So that was a 1, a -1, and a 2. And now I'm going to replace the last column with 3, 0, 0 to get the Z matrix. Okay, and then I'm going to find the determinant of that. You can see that because this is like kind of like an app, I can just go in and edit things. I don't have to retype everything from scratch. All right, so that gave me a determinant of 9. Okay, everybody okay with finding the individual determinants? Anybody questions on that? Okay. All righty, so back to my notes. I've copied the determinants down. And again, according to what I have up here, okay, you can see how I can use the values that I've got. Okay, I have the values that I've got, and I can use them to actually figure out what X, Y, and Z are. So X is going to be the determinant from the X matrix, which is 3, over the determinant of the coefficient matrix, which is right here, which is 3. Y is the determinant from the Y matrix over the determinant of the coefficient matrix. And Z is the determinant of the Z matrix over the determinant of the coefficient matrix. So you can see X is going to be 1, Y is going to be -2, and Z is going to be 3. Okay, so this is kind of how you use it to get your individual variables. Now you can imagine, say this changed a bit, okay, this A matrix changed a bit, maybe one of your coefficients changed, and you wanted to just recompute Z. What would you have to do? Well, you'd have to recompute the determinant of A, because A would have changed, and you'd have to recompute the Z matrix, okay, unless the last column is where it changed. Okay, in that case, you're good to go. But say one of these other values changed, you'd have to recompute DZ, but then you'd get the value of Z right off the bat. You wouldn't have to mess with Y and X, okay, because they're handled separately. Okay, so see how it's easy to solve for just one variable if things change. Okay, so it's easy to just go back and dink with one of these matrices. Okay. All right. Here's a question that you might want to answer. Okay, it's always good to know when things are going to break. So question 4 down here says, when might you run into trouble using Cramer's rule? So I'll rephrase it even a little better. When will Cramer's rule break? When will Cramer's rule break? Okay, you probably want to look at this up here. where I'm actually solving for X, Y, and Z. When will Cramer's rule break? And again, feel free to just unmute and talk. Okay. Yeah, pretty much. Jesse is putting something in the chat and he's saying, when the determinant of the coefficient matrix here, D, when D is 0. Okay, see all these D's in the denominator? If D is 0, you have undefined answers. Okay, so if D equals 0, okay, it won't work. Okay, so basically, if the products on your downward diagonals equal the products on your upward diagonals, you've got a singular matrix, okay, and you can't find its determinant, okay? Remember, we said that also wouldn't work if you were trying to find an inverse, okay? Not every matrix has an inverse for that reason, okay? There are some matrices that have 0 determinants, okay? So that's when Cramer's rule breaks. Okay, so pretty much that's Cramer's rule. I just have one more thing to share with you, and that's a U-try. Okay, so what I have here is a system of 3 equations in 3 unknowns. Okay, 3 equations and 3 unknowns. And what I need you to do is walk through the steps. Now, I've labeled the steps for you. Okay, so you don't have to frantically refer back to your notes if you're taking notes. Okay, so here's your system. Put all the equations in standard form. You'll notice this one, the third one, is not in standard form. It needs to be before you can start. So you get your X's, Y's, and Z's on one side and the 5 on the other. Build a coefficient matrix from your system and find its determinant using Symbolab. This is going to be D, okay? Then build your X, Y, and Z matrices and find their determinants, okay? All right, so here's what I'd like to do. You try this one. This is probably going to take at least 5 minutes. Okay, so type done when you finish. Okay, and again, you're going to need Symbolab matrix. Okay, use. Okay, if you search in Google for Symbolab matrix, you'll find it. Okay, and if you get stuck, just chat to me privately and I'll work with you. We'll take another minute or so on this problem. I've started it for you if you're still working by putting the system in standard form and building the coefficient matrix. So another minute or so and we'll come together. Okay, everyone, I know some of you are still working, and that's fine. It takes a while to get into the flow of using anything new. Okay, but let's come together so we can make sure we're on the right page. We're all together. So the first step was put the equations in standard form. And you can see what I did with this last one. This last one was not in standard form because I had variables on both sides of the equal sign. So I subtracted the 3y and subtracted the 2z from the side that had x. Okay, and I got this equation, which is now in standard form. Okay, then I'm able to build the coefficient matrix, which is just everything to the left of the equal signs here. So 2, 5, 4, 1, 4, 3, 1, -3, -2. And then what I need to do is just go over to Symbolab and put my coefficient matrix in and find its determinant. So it's a 3 by 3. All right, and it is 2, 5, 4, 1, 4, 3, and 1, -3, -2. Right, so that's my coefficient matrix, and I'm going to find its determinant, and I got -1 as the determinant. Okay, anybody have trouble getting that far? Anybody need questions answered at this point? Okay, so my determinant here is -1, thanks to Symbolab. Now all I need to do is I need to start with the same coefficient matrix. And I know this is tedious to watch me do it, but it really makes it stick in your mind how to do it. So just bear with me. I'm copying the coefficient matrix over 3 times for x, y, and z. And then I'm going to erase the appropriate column in each matrix. So here, I'm erasing the x column. Okay, here I'm going to erase the y column. And here I'm going to erase the z column. And I'm going to put my right-hand sides, which are up here, 4, 1, 5. Okay, so that's how I build my x, y, and z matrix. And then in order to find the determinants, you can see what I have here is I'm going to solve for x by putting everything over the determinant of a, which is -1. So I'll set this up. So I'm putting the determinant of a down there. And then I just need to find the determinant of x, determinant of y, determinant of z. So I'm going to do that over in Symbolab. Okay, and I'm starting again with this coefficient matrix. Okay, so that's the way it is here. I'm just going to replace my first column with 4, 1, 5. Okay, and then find that determinant. So d sub x is -3. Okay, I'm going to put back what was in that originally, which was 211. And I'm going to replace the middle column, the y column, with 415 to find the determinant of y. Oops. Go. The determinant of y is 2. And I'm making notes of that as I go along. Okay, replace the original coefficient matrix values here, which were 5, 4, and -3. Okay, so back to the coefficient matrix, and then replace the last column, the z column, with 415. And find that determinant. Okay, and that is a 2. A -2. I was going to say, I don't think it went. Okay, so here it's a -2. My Wi-Fi is a little bit slow today. Okay, so -2 is my z determinant. Okay, and I've made notes of all of those. And I'm going to come back to my worksheet, and you can see I've plugged in d sub x, d sub y, d sub z. Anybody questions on finding the determinants? Questions on finding the determinants? How to build them in Symbolab? No? Okay, so then I can just do some arithmetic here. -3 divided by -1 is 3. 2 divided by -1 is -2. And -2 divided by -1 is 2. So you see I have my variable values down here. And again, if only one thing changed in my system and I wanted to say recompute y, I just have to recompute the determinant of a and the determinant of y. I just have to build these two matrices. I wouldn't have to build the others. Okay? So anybody questions on this process? Questions on the Cramer's process? Okay. I am going to stop sharing and come back to the meeting. And I'm going to ask if you've got questions on anything. Questions on anything?